So I have a few slides prepared, and I've got like 30 different presentations I can pull into and tap into as we need to make sure this is as relevant as we can. But the purpose of this talk is really what's new in Angular. So I want to talk a little bit from the context of you guys all know what Angular 1 is, you guys have all built something with Angular 1. I want to talk about some of the perspectives behind why we did Angular 2. And then we're going to get into, as he said, a little bit of live coding, where we'll actually dig into some of the core concepts and actually hopefully demonstrate how easy it is to get started building an Angular 2 application. So let's kind of dive in here. So relatively recent in Angular news, it was actually September 14th, so this year, after almost 2 years of effort, we announced Angular 2.0.0. And so this was really exciting for us. And if you look back at the history of Angular, it can really instruct you a little bit in kind of where we've come from and where we're trying to go. When we built Angular 1, the web was a very different place. So Angular 1 was in some ways a reaction to this idea that the web was kind of becoming for the first time a platform that you could build instead of just web pages and websites. You could build full applications that are interactive and build great user experiences. And all we had really back in kind of 2009 was jQuery and a couple other fledgling frameworks. And jQuery was a fantastic first way to start manipulating things on the screen and giving a higher level of user interactivity that didn't require a full round trip back to the server, but it wasn't really how you wanted to build applications. And so Angular was founded by a guy by the name of Miško Hevry, or Papa Miško, as he's sometimes called in the community. And so what he wanted to do is he wanted to kind of go back to the drawing board and say, if we could build the browser in a way that would let you build applications how you kind of want to do that, what would that look like? And so he wanted to take into account, okay, how do we manage state? How do we manage data? As well as things like how do we make these applications scalable and maintainable? And so Angular 1 is like at this point, one of the most popular frameworks kind of out in the world of developers. So we've got kind of millions of developers building with Angular 1. We've got hundreds of thousands of projects. And we're very excited and happy about that. And we're continuing to invest in Angular 1. But what ended up happening was as we've reached out to these kind of hundreds of thousands of application scale, a few cracks have kind of ended up showing up when you build applications. So everyone here has probably seen $scope inside of your controllers, and you've seen $root scope and things like $scope.apply. These are all things that end up, when you build complex applications, maybe you're getting up past 10,000 lines of code, or you're getting up past 100,000 lines of code. These things start breaking down where it's very hard to understand what's going on in your application, which makes it very hard to debug what's going on. And so another side or another aspect of that is that when you end up having kind of hundreds of controllers or hundreds of components within an application, or thousands of components within an application, the Angular 1 mechanisms for change detection end up becoming a little bit slow. So if you look back at how we did change detection in Angular 1, we basically, and I'm grossly oversimplifying this, but we basically looked at all the expressions in your application that a user could see, and we evaluated all of them. And then we did it again to see if anything had changed, and if anything did change, we'd run it again, and we'd run it again, until the entire state had kind of stabilized. And so performance was another big area that we were thinking about in terms of how can we make this experience better for developers. So when we think about kind of some of the drivers for rewriting the framework as we did from Angular 1 to Angular 2, there were a number of things that were really born out of this idea that we've got millions of developers, we've got more than 6 years of experience building this framework. What would we do differently if we had the chance? And so we gave ourselves that chance. And we really focused on things like improved performance, modern web standards, something that I'll talk about a fair amount called DOM independence. And then lastly, the idea that Angular doesn't necessarily just have to be just a framework, that we can go and focus on more parts of the developer experience and extend it out to a little bit more of a full platform. So I'm going to go into each of these. So first, performance. So I talked about that Angular 1 digest cycle that we were evaluating all of those expressions in. That really doesn't scale very well, but it's very hard for us to fix from a performance standpoint because we don't have a semantic understanding of what's going on within your application. And so in Angular 2, and we've actually backported this back to Angular 1.5, we've moved to more of a component model. So everyone here that's done Angular 1, are you guys still writing in controllers, or are we writing in components? How many people are writing in components? Okay, so about half of you. So if you're building Angular 1 applications today, you can still keep doing that. You can still do a lot of great applications, but I would definitely recommend that even if you're staying in Angular 1, start looking at using components, because these things will give you a more maintainable code base, and it will also prepare you from a skill set, from a development standpoint, for migrating to Angular 2. So that's a big deal. And so when we think about an application in Angular 1.5 or in Angular 2, your application is really just a tree of components, right? At the top, you've got your root component, and then inside of that component, you've got component composition. So we've got other components, and then those components get nested further and further. And then for code management purposes and for giving the context of what's going on at any part of your application, we also have the concept of modules, where every component belongs to exactly one module within your application. And I'm going to demonstrate all this in the live coding, so this should all become clear here. Another thing that we did that's a really big game changer when it comes to performance is this idea of compilation. So in Angular 1, we actually had a compiler, but we never talked about it. No one in Angular 1 really had to know that there was a compiler unless you were doing some very advanced kind of dynamic content loading. So in Angular 1, what would happen basically is we would use the browser as the compiler, right? We would take a string and we would pass it into the compiler, and it would figure out, okay, this template has these directives on it, these components in it, and then we would figure everything out at runtime. But that actually ends up having a bunch of kind of performance impacts. And so we've just done things a little bit differently in Angular 2, where we've actually taken out the compiler from the Angular core, and we include it as a separate component. And the magical thing that we can do by separating the compiler for Angular from the rest of the Angular framework is that we can take this, what used to be runtime, being running in the browser, so being evaluated on the client side by the user's computer, and we can actually make that a server-side thing, so that instead of the user running it, you're running it as a developer. And so we call that ahead-of-time compilation. And so if you look under the hood, what's happening within Angular, we're actually taking all of your HTML, your JavaScript, your CSS, and we're converting all of those things into JavaScript commands, right? So when you put in a template or in a controller that kind of view in Angular 2, where you say, hey, here's my div tag, and here's the structural directive that says whether or not I want to load this thing based on some variable or some parameter, that actually becomes JavaScript. That actually becomes a literal if statement within code that's virtual machine optimized, and then that runs really fast within the user's browser. And so when we talk about performance, this is an example of a flame chart. So this is a company called Lucid Charts. So Lucid Charts is basically a web kind of diagramming, flowchart design application that's very popular, at least in the US. I don't know how popular it is here. But so their entire application, except the WebGL context for rendering, is fully built in Angular 2 and is in production. And so this is what it looked like when they first started doing things with Angular 2, where you would bootstrap Angular at the beginning, and then Lucid Chart, the whole document would finish loading, and then the computer that the user was using would take kind of hundreds of milliseconds to go ahead and compile all of those templates at runtime, or what we used to call just-in-time compilation. So take all of the HTML and turn that into that VM-optimized JavaScript. And then you had the first Angular tick where you could actually start running your application. And so this was a huge problem for them, but they were able to adopt and switch to ahead-of-time compilation. And that entire middle section of that was completely eliminated. And what ended up happening is, so you're doing that compilation step as a developer on your machine, and then we just save out the generated code for you, and you ship that down as part of the bundle. And the other big win with that is instead of having to ship the compiler down, you can actually save all of that bundle size. And so when you're building mobile applications or any sort of web application, bundle size is a really big deal. Rob had some fantastic stats that he was sharing at another conference today, where it was something like the average application is 1.4 meg. It takes more than 10 seconds to load on a 3G connection, right? And at 10-second load time, you're going to lose a huge percent of your users. And so focusing on this idea of bundle size and shipping as little code as possible down to the browser at a time is a huge win. You had a question?
Yes, two questions actually. One, does it improve the SEO of the...
So ahead-of-time compilation has nothing to do with SEO. Okay. We have another project for that called Angular Universal, and I'll talk about that a little bit.
Second thing is, does it put extra load on your own server when, I mean, if you have the client-side rendering, you kind of have sort of parallel computation going on.
Sure.
But if you have this server-side rendering, you can.
So once again, this is, I'll say it's build time compilation, not serve time compilation. So I don't have to recompile my Angular application for every request that comes in.
Okay.
I, as a developer, anytime I make a change, I want to be doing that compilation. So it's the same corollary to if you've ever done any sort of minification or uglification of your code, right? A lot of us have gulp tasks that are helping us to process our Angular apps. It's the same place where you do that step. So you do it kind of once at build time. Yeah?
You mentioned that you do VM optimization.
Yes.
So do you optimize only for V8?
So in terms of performance characteristics, in terms of optimizations that we do, we found that all of the browser virtual machines operate very similarly in terms of what's fast and what's slow. So for example, if you document.create element in certain contexts, in certain ways, that's always fast across all the browsers. Good question. So we do care about V8 a lot, but Angular is intentionally has a lot of focus on making sure that it works in all the evergreen browsers. So I talked about how Angular 1 in some ways was a reaction to jQuery and the web, the modern web in its kind of fledgling years. But you can also think about Angular 2 as a reaction to the web as it is in 2016. Which the web as a platform has actually come a really long way in terms of what it's capable of doing, as well as kind of the ecosystem that we've seen. So the first thing that we're big fans of is progressive web applications. Have you guys heard of progressive web applications? Awesome. Anyone building them? Probably far fewer of you guys. So progressive web applications, for those that don't know, is the ability to take advantage of something called a service worker, and we progressively, on browsers that support it, add more functionality. And there's two kind of main things that we do with service workers that can be really impactful when you're building any sort of web application. The first is we actually can act as a proxy layer in front of any sort of network requests that are coming from your application. And so by acting as that proxy layer, we can actually enable a fully offline use case of your application. Because when a service worker gets installed, it can say, hey, I'm going to need these 30 assets, maybe these JavaScript files, these JSON objects, and these images. And then the next time the user tries to visit your page, for example, from a home screen icon, we can see, hey, we have no internet connection, or we can just be optimistic and say, hey, I know my cache is going to be probably the best place to get this from, and we can instantly serve that to the user via web technologies without any sort of round trip. And so you get this kind of very app-like experience, which is a pretty big deal. The other thing that the progressive web apps and service worker in particular gives you is the ability to actually run your JavaScript off when a user is not interacting with the application. So most of the time, the only time you can do anything with a web application is when a user is sitting there in the browser staring at your app. But with service worker, we can actually interact with something like push notifications coming from the Google Cloud or the Firebase Cloud, and then wake up a JavaScript thread and say, hey, this thing happened on a server, what do you want to do with that? And then you can render things like notifications within your application. One of the best, most well-known examples of that is if anyone here uses Facebook. About 6 or 7 months ago, I actually uninstalled the Facebook app from my phone because it was eating my battery and taking up too much space. And then I went to facebook.com on my mobile device and it said, hey, would you like to enable notifications? And I said yes. And so now Facebook is able to send me push notifications via their web application. And that's entirely in JavaScript, which is a very, very cool and exciting thing. So that's basically progressive web applications. And we can talk for hours about kind of any of these topics. So if you guys want to know more about that, let me know. The other thing that's happened is ECMAScript as a standard. So if you guys don't know, JavaScript as we kind of know it and as most of you are writing it today corresponds to what we call ECMAScript 5. So the kind of latest and greatest available on all the browsers, virtually 100% supported across the platform. But we have a bunch of new both semantics as well as a bunch of new features that try and make it easier to build web applications. And so every year now, the standards body, the TC39 body that decides how should JavaScript work, they're coming up with a new version of the standard and they're trying to push the web forward in terms of what you can do with it. And so if you compare Angular 1 and Angular 2, Angular 2 is actually much simpler of a framework. And so for example, in Angular 1 we have something like 56 different directives that you can learn. So ng show, ng hide, ng cloak. And so there's all this kind of Angular stuff you have to learn. But in Angular 2 what we try and do is we really try and lean on what is available in the web. And so we're taking advantage of these things like classes. So in ES5, you can create objects, but they're still functions under the hood, right? Weird.
Blackout.
We'll see if that comes back. Within ES6, or the ES 2015 standard, we actually now have this idea of pure classes. And so we take advantage of that throughout the Angular 2 kind of world. So an example of that is in Angular 1, when you wanted to build a service, you would use a factory or you'd use an Angular.service, and you would kind of not really understand or know what's going on under the hood in order to make that available to your application. Whereas in Angular 2, it's literally just a pure class that we use our injector and dependency injection to ensure that a singleton exists for you, but it's 100% a pure class that is running in JavaScript. So that's really cool. Another thing that was hard in Angular 1 was separating the different parts of your application into maintainable chunks. And so with ES6, we had this idea of modules where I can import something from something else, right? So I can split up everything up at the file level and then only import the parts of JavaScript or of another library that I need. And so we take a huge advantage of that. There's also a standard that we're leveraging called decorators, where you can annotate what's going on within a class, and we take advantage of that whenever you're building a component or a module, and a couple other use cases that I'll get into in the demo. And then I'll just hit more here. Item E, so TypeScript. So a lot of developers are very afraid when we start talking about TypeScript and how we kind of love TypeScript in a lot of ways. But almost every developer I've talked to, actually every developer I've ever talked to, after spending about a week in TypeScript, they end up loving it. Because what TypeScript fundamentally is from our perspective is it's the latest and greatest JavaScript. So that's all of the ES 2015 standards, all the ES 2016 standards, and whatever comes out kind of next, plus types. So instead of having to infer manually when I'm writing my code what something is or what the items in an array are, which might not always match up, and that's a big source of bugs, we can actually use typings to annotate and understand what's going on in your program at a much deeper level. And that also allows us to build much better tooling to help you do those sorts of things. And we'll give you some examples of this a little bit later. And then lastly, so a corollary to the idea of having modules in ES6 now, we also have a set of bundlers. So these are basically libraries or programs that take your application that in a bunch of different pieces and pull them all together into an ES5 bundle that you can ship down to the browser that's very performant and very fast. And so there's System.js, which is very, very powerful, but a little bit more work to configure. There's something like Webpack, where we've done a lot of work to make sure that it automatically detects the environment that you're currently operating in, and then pulls everything together without you really having to do anything. And then lastly, there's things like Rollup, where it can be very performant, and it can do things like tree shaking, where it will actually eliminate parts of the Angular platform that you're not using, or any library that you're using, and remove that from your bundle, right? Because if you import, for example, Angular material, but you only use one component out of 20, you don't want the other 19 in your code base. And so we do this with all of them a little bit, but Rollup is typically the best at that level of tree shaking. Another thing that I mentioned that Angular 2 is a big fan of is this idea of DOM independence. Oh yeah?
Sorry, for the modern web,
Yeah.
where's HTTP 2?
Everywhere.
I don't see it on the slide.
So Angular does not really rely on HTTP 2. So if you do bundling, it's not as necessary. So for example, if everyone had HTTP 2 right now on the client side, we wouldn't necessarily have to do bundling, right? Because I can use a single connection to the server to download 400 different files without as much overhead. But what we end up seeing is there are other performance reasons why you want to do this level of bundling. The biggest advantage we can take, and I actually love how Firebase does this, is you can say, hey, when someone loads my index.html, here's the 3 other files they're going to need. They're going to need my JavaScript bundle, they're going to need my CSS file, and they're going to need this icon or this image. And so, do you guys know what HTTP 2 is? Okay, it looks like most of you do, but for those of you who don't, HTTP 2 is the new standard. It's the successor of both kind of HTTP 1 and Speedy, which was an experiment by Google, to try and say, hey, our web browsers are they're solving a much different problem than we used to do, where I think IE would originally limit it to 2 simultaneous connections to the server at any given time, and now I think we're at like 8 in Chrome or something like that. Maybe that's really old data. But we can use a single socket connection to the server and then pipeline multiple file streaming simultaneously via HTTP2. And so it's really designed to lower the overhead of interacting between clients and servers to reflect what's happening in our web applications today. So we definitely benefit from HTTP2, but we're not requiring it or built on it in any way.
Okay. Cool.
And is that what the server must support, the HTTP2?
What's that?
The server must support that?
Yes, yeah. So both your browser has support HTTP2 and the server. Fortunately, as of less than a month ago, Firebase turned on, they flipped the switch on HTTP2 support for their entire hosting. So if you build an Angular application and type Firebase deploy, you will be taking advantage of HTTP2 hosting, which is very cool. All right. So Angular 1, oh yeah.
Really short question. Could you upload these to Meetup when we're done? So
Yes,
we can,
absolutely.
Thanks.
Yep. Yeah, I'll share both the slides and the code. I'll try and add them to Meetup. I'll also tweet them out. So if you guys want to follow me. Shameless plug.
We have a video posted later. So.
Oh, the video. Awesome. The other thing that we're doing in Angular 2 is this idea of DOM independence. So before we would pass in a template and let the browser kind of evaluate it and figure it out. But that actually came with a number of different limitations where we're dependent on what's going on in the browser. And so you couldn't necessarily predict what will renderer, and we propagate out DOM changes. And so we aren't dependent on the DOM, and we actually, I'll talk about an example here where you don't actually render to the DOM at all. But we also don't depend on anything like virtual DOM, right? We're not emulating a DOM, figuring out what changed, and then propagating changes out. We operate on the more pure forms of your classes and your components. One of the more fantastic things that we can do because of this is we can run Angular everywhere. So when we talk about everywhere, we're talking about mobile devices, desktop, web, as well as server. So there's a project called Ionic, which is a way of building mobile applications that run and can be installed to your device, so you actually have a presence in the App Store, but it's running within a web view. And so Ionic has done a fantastic job of building components, and they're entirely built on Angular that make it feel like you write your application once in HTML and JavaScript, and then they apply CSS for you using their components to make it look and feel like the target platform, which is a fantastic way of doing it. But with Ionic, you're still living in the web view world. So the user is still running a browser instead of kind of an application. But there's also another team that we work with from a company called Progress, or formerly known as Telerik, where they have what they call native script. And so native script is really cool because you build an Angular application using what looks like HTML and kind of all of the same JavaScript that you're used to writing or TypeScript that you're used to writing. But then instead of rendering out to HTML, we render out to native widgets. So when you have a text edit field, instead of that becoming a browser and an input field, that actually becomes an Android or an iOS native widget. And so when you have hundreds or thousands of these kind of UI components on a screen, and you're flicking through them on your device, that can help performance. And while you can achieve performance using any kind of mobile technology, and we do try to make that great for no matter what sort of technology you're using something like NativeScript can help with that. Another place that we take advantage of this DOM independence is using Electron. So if you've ever used an application like VS Code or Atom, those are both Electron applications. And so Electron basically gives you a Chromium web browser plus a Node server. And so within the Chromium web browser, we can run Angular just like normal, or you can run it within the Node server and get a little bit of performance benefits, and also get access to any of the native APIs. So if you want to access the file system, or even if you wanted to, for example, we were at a .NET conference today, so if you wanted to ship a Windows app and take advantage of like a HoloLens connection, you can do those sorts of things in an Electron app, which is very cool. And then the last one, which I said I would get back to a little bit, is this idea of Angular Universal. And so Angular Universal is the concept that we can run your application entirely server-side. So instead of running it in a separate thread, we're actually going to render the entire application server-side, and then we can ship down the finished HTML. And then if you want, we can even bootstrap Angular on top of that. So you're trying to get the best of both worlds, where the user's browser doesn't have to do any rendering up front in order to get that fully visualized experience. And then you get any sort of SEO benefits or Twitter or Facebook preview benefits. But then you still get the interactivity that comes from a client-side single-page application. And so we've got Angular Universal bindings for both Node.js and ASP.NET. And that's a project that we're spending a lot of time thinking about how do we make this even better right now. Another thing that you can do is take advantage of web workers. So a service worker is actually a specific type of web worker. But what a web worker is fundamentally, it's a second thread or an nth thread for your JavaScript application. So although you write JavaScript code typically in a very asynchronous manner using callbacks and all these things, it's all still running in a single thread. And so if you're using some intensive data processing, that's actually going to block the UI of your application. It'll prevent a user from doing input, or they'll see stuttering when they're scrolling through the application. But a web worker allows you to do all of that processing off of the main UI thread. And because of how Angular is DOM independent, we can actually run about 80% of the Angular framework in a web worker, and then we just propagate back the DOM changes to a renderer that lives on the UI thread. And so this can have huge kind of performance benefits, and we make this relatively simple for you, which is very cool. And then lastly, because we're DOM independent, you can actually build custom renderers. So just like NativeScript built renderers that target mobile applications, when I first joined Angular, I was at a conference and I saw someone that was rendering out to light bulbs. So they had a series of light bulbs, and then using like ngIf, they could say, turn on this light bulb and turn off this light bulb. Which I don't know why you would want that, but it's kind of a cool idea, right? That we're not artificially limiting you to the web as a technology or to DOM as a platform. It's really hard for us to know how many people are using Angular for kind of two reasons. The first reason is that most Angular applications that are built in the world are actually line of business applications or private within a business. So whether it's a dashboard or whether it's a work order management system, we don't necessarily have visibility to any of those because none of them are public internet facing. And then the other reason is because of how we're taking advantage of the modern web, we're not polluting the global namespace anymore. We're not forcing you to put ng-app in your HTML tag anymore. And so it's actually very hard for us to detect Angular 2, as well as because we can, for example, tree shake out most of the platform. And so the best stand-in we have for those metrics for us to understand how many people are using these things is unique visitors to our documentation site, so angularjs.org and angular.io. And so if we look back to September, on our doc site we had about 1.2 million developers still building with Angular 1. But we already, even though we just released in September, we had over 600,000 developers building with Angular 2. And so we've been very, very pleased with the kind of speed of adoption and the number of applications that are already in production building with Angular 2. And so we're continuing to invest in Angular 1, and that's still going to be a thing. And what we've said in terms of guidance for how long we're going to continue to invest and support it is basically until these graphs switch. So until the majority of developers have migrated from Angular 1 to Angular 2, we're going to continue investing. And the main area that we're continuing to invest in Angular 1 is backporting these features from Angular 2 and making it easier to upgrade, as well as all the necessary kind of security fixes and things like that. So I think soon, most of you are probably using Angular 1.5.8, I think. You'll probably soon be seeing an Angular 1.6 come out, for example. So the last section that I wanted to talk about here is the idea that we've moved away from just a framework into worrying kind of about all of the parts of a developer's experience. And so we're really trying to be much more of a platform, whether it's doing something like PWAs, so making it easy to ship these kind of installable experiences to mobile, whether it's rendering to different targets like native, desktop, whether it's helping you to optimize your application, running code on the server. There's also things like code splitting. So I'm actually going to do in a live demo here a code splitting example where we can actually pull apart your JavaScript application and try and minimize the amounts of pieces of your app that are in the critical path for rendering. So once again, that's kind of relentlessly driving the idea of performance. We also have a CLI, which I'll be demonstrating the use of, that will help you scaffold out your application and really hopefully help you build an Angular 2 application in a testable, maintainable manner a little bit faster. We're also working on things like language support via IDEs. So right now we're primarily focusing on VS Code, but we're doing it in an extensible way. So support should be coming soon for like Sublime Text and WebStorm and kind of all of the different IDEs that people use out there, where we want you to have an intuitive understanding of what's going on in your templates, and that should be matched back to your components in a very useful way. And I will probably have that demoed a little bit. And then, as always, focusing on testing, making sure that you can do both end-to-end testing and unit testing with Karma and Protractor. Animation, so we've got a lot of state transitions that happen within applications, and we want to make it easy for you to animate those and have these kind of beautiful experiences for users that hopefully is impacting them in a meaningful way. And then finally, we're worried about things like internationalization and accessibility. How do we broaden the reach of your applications And so these were all things that we weren't really thinking about when we started building Angular 1, but are built into the idea of what we're trying to do with Angular 2. I just wanted to run down a couple recent announcements. So we just had Angular 2.2, was announced I think this week or a couple days ago. Upgrade Fire Booster, which is one of the coolest code names I've ever seen. It's a drop-in replacement. So we announced that we switched to semantic versioning with Angular 2. So that means you're going to see every month or so, you're going to see a new minor version, so that second digit. And then whenever there's a breaking change, we're going to see that major digit, or that 2 is actually going to shift. So at some point you might see Angular 3 or Angular 4, but it is not the sort of rewrite or the major migration that Angular 1 to Angular 2 was. Yeah?
I have a question about the versioning.
Yeah.
Why for Angular 2 was choose to create a new repository?
Sure. So the team decided, and I don't have all the background because I wasn't on the team when we started with Angular 2, but we started a new repository because the underlying assumptions that existed in Angular 1 about how we built it, not necessarily how you build applications, but how we build Angular, didn't exist anymore. So this idea of, for example, switching to DOM independence, that's a fundamental enough change that we couldn't add that back into Angular 1, so we needed to start over.
Will just a branch do the same job?
No, because we started from scratch, so it was a ground-up rewrite. And actually, Angular 2, if you look at both kind of the size of the framework as well as the complexity, it's actually much simpler. And if we had just forked or branched Angular 1, we wouldn't have had those benefits, both in terms of performance as well as just the complexity of what Angular is doing. We also released a new beta of the Angular CLI to go along with that, beta 20. And then one of my favorite features in the CLI recently is this idea of code splitting and lazy loading. And so we actually have a Webpack plugin called ngtools/webpack that does this for you. So you don't necessarily have to use an Angular CLI project to do that. So a lot of people ask what's next. We are figuring that out right now. So we're doing kind of all of the planning and prioritization. We've got a spreadsheet with all of the different components within Angular and all the things that we want to get done with those, and we're figuring, okay, where do we need to invest, what needs to come first, what needs to come second. But the first and foremost thing that we've heard kind of over and over is, how do we focus on making developer experience better? So keep the framework as similar to as it is today as possible, minimize breaking changes, but make it easier for you guys to start using and to migrate to it. So we're very excited about those sort of things. So I'm going to switch to the live demo in a minute. I think we're going to take a little break. But these are the rough 5 goals of what we're going to try and build. So I'll go over those in a second. So I think we're going to take a break now.
Yeah.
Perfect.
Cool.
All right. So we've got about, it's 8:30 right now. So anyone that needs to leave before 9, I'm going to try and do this as quickly as we can. So really just laid out kind of 5 goals, and we can tweak this if you guys want to see something different. But I'm going to start by showing off the CLI a little bit, and then I'm going to get into this idea of component composition and how components can actually communicate with each other via inputs. Then I'm going to show you guys how to build a routable application so that we can map different URLs to different states within our app. And then we'll do a little bit of RxJS, so pulling data off of, for example, a web service. And then if we have time, I will actually demonstrate how easy it is to do lazy loading. So the first thing I'm going to do here, that I've actually already done, is I have the Angular CLI installed, and I ran a command called ngnew. So if you just type ngnew, and then you give it the name of a project, it actually scaffolds out an entire application. And so because that's a little bit internet heavy, I've done it ahead of time here. And so this is just the standard application that the Angular CLI generates for you. And so it comes with a bunch of testing. So there's Karma configurations, there's Protect configurations. It generates a package JSON, so all of your dependencies come in here. It actually does a git commit of this initial state for you. And then it also scaffolds out like your index.html all the way down to that root component. And so if we look at this root component, it just has a single property called title, or we say app works. And then you're going to see a very simple template that should look very familiar if you've done any sort of Angular 1 where we render that out. And so in the terminal here, I'm going to run ngserve. And so beyond just scaffolding with this ngnew, it's also kind of an iterative development environment. So it's going to, via the ngserve command, it's going to spin up a local development server on port 4200, and it will transpile all my code, it will bundle it, it'll create all the source maps, and then if we pull up a web browser, we should see app works. So if you recall, that was the HTML template that we had right here. So I wanted to first start off by showing a little bit how easy it is to add something like material design and to start adding a little bit of beauty into your application in a way that I, as a developer, am not very good at doing. Yeah, do you want to ask your question while I'm typing here?
Sure. Is there any way to specify the port?
Yeah, sure. Dash port.
Is there like a configuration style? Or?
Yep, so there's this angular-cli.json, which configures where you want some of your folders, how you want to configure your TypeScript, what sort of environments you want to have. So it's somewhat extensible today, but at the same time I will say the Angular CLI is intentionally a bit of a black box. So under the hood of the Angular CLI, we use Webpack to do all this sort of automatic discovery of what's going on in your application, but we don't expose the ability to change the Webpack configuration or add plugins. That's intentional because Webpack is undergoing change, and the browsers in general are kind of standardizing how module loading should work. So we wanted to protect developers from getting into the weeds on that in a way that is going to fundamentally change over the next few months. So if you use Angular CLI, you should be able to keep using the Angular CLI, is our expectation. So I've imported a material module. I'm going to add that to my application module here. Material module for root. So this is the root module. And then, so that has now added that to my application. So any of the directives that are available as part of Angular material are now in my app. And then I'm going to go ahead and copy some CSS in that I have prepared so that it pulls in both the default theme from Angular material as well as just some reset style sheets so that it doesn't look as terrible. We'll go ahead and save that. And then let's go into our HTML and swap out that H1 with an MD toolbar. And then I'm going to set the color to be the primary color. Perfect. So I've swapped on a basic H1, and now I'm using the directives that are made available as part of Angular material. And if we go back to our application, we now have this nice purple, mobile-friendly toolbar, right, that makes it feel like a material design application. All right. So next thing I want to do is let's pull in some information into this. So let's do a child component. So within our app component, I'm going to create a list of things. And so I'm going to use the CLI here. I'm going to say ngg for generate. I'm going to generate a new component, and I'm just going to give it the name list. And so what this is going to do in the background, it's going to scaffold out a new component for me called list component. It's creating tests. It's created a default template for me. And then it's also added it to my app module so that it's available throughout my application. So if we now use that list, so I'm going to add this here. I'm going to say app list. And we refresh that. What you're going to see here is now list works. So this is the kind of basic idea of component composition. So in my app component, I'm now including an app list component. And so let's do some RxJS a little bit early here. And so within my list component, I'm going to import something called HTTP library here. So I'm going to import HTTP from Angular HTTP. And then, so I've been in the Netherlands and Belgium for about a week and a half now, and I've learned that a lot of people here really like beer. So I'm going to actually pull from a beer API, because I thought that might be interesting. So I'm going to use dependency injection to get an HTTP client, and then I'm going to create a local member property called beers. And then let's say this.beers equals http.get. We'll just use a path for now. And then I'm going to take the response that I get back, and I'm going to get the JSON from the response. And then I'm going to get something called, I believe it was data. And then I need a path, so I've got this nice URL for my beer API. I tried finding an Amsterdam specific beer API, but one does not exist. So startup idea for you guys. All right, I may be getting this data wrong, but we'll see very shortly, I guess. So now I want to use this local member. So we've got this beers, which is an observable of arrays of beers. And so what I can do here is I'll just blow this away, and I'll use an empty card. And then within my empty card, I want to do I want to iterate over this. I'm going to use a structural directive called ng4. I'm going to say let beer of beers. And I want to unroll the observable, so I'm going to use what we call the async pipe. And that means in here, I should just be able to say beer.name. And so we'll save this and we'll give this a try. So once again, I've got a material design card. I'm creating a material design card for every item in the beers list that's coming from an observable. And then I'm just rendering the name out. So let's see what we've got here. And it worked. So this is now making a live network request to a JSON backend of beers, and then it's rendering it out as this nice material design cards. So that was pretty simple, but let's make it a little bit more complex. So let's make a more beautiful card. So we'll say MD card header, wrap that here, and then let's do an MD card content, and we'll put the beer.description here. All right, and let's see if that worked. So one of the things that we want to do next here is we want to use a little bit more component composition, because I've got this nice design for what a beer should be rendered as, but I might want to reuse that rendering kind of throughout my application. So what I'm going to do is, instead of a list here, I'm going to generate a new component, and I'm going to call it item. And so within that item, what I want to do is I'm going to actually take most of this HTML here, most of this template, and I'm going to add it at the item level so that it's more reusable. And then I'm going to go back here, I'm going to take this ngFor, and I'm going to actually iterate, instead of over cards, I'm going to iterate over my item component. So in my list, what I should be able to do is make an app item, and then I'm going to paste this ngFor. So it's still going to use that same data on the list component that we had access to before, but we're just going to iterate over these items. And so if we've done this right, which looks like we've not, it's just, so I mentioned that we've got language services coming. I'm operating on the early alpha, so you're going to see errors where it hasn't actually populated across files. But this should have worked. But I did something wrong. Oh, I didn't actually pass in. So we have a component composition. So we're loading the app item underneath the list for every item. So that's why we have a bunch of empty cards. But there's no beer content within that item component. So what we actually want to do is we want to, on the item component itself, we want to create what we call an input. And then I can add a property to this class just by saying @input, so that's a decorator, and I'll say beer. And then that will then be available to bind to. So I'll use the square bracket syntax, and I'll say the beer that I want to pass into this is just beer. And so the second beer here refers to the iterator that I've got. So if that worked, and I haven't made any typos, we should now see that same list of beers now being rendered kind of at a few different levels. And there's actually a really cool tool called Augury, where you can actually inspect the component hierarchy that exists within our application. So you can see, if I can make this bigger, sorry if it's too small, just feel free to yell at it if it's too small. You can see I've got an app component, so that's my root component. I've got a toolbar, and then the material design library has a subcomponent called MD toolbar row that they automatically created for me. And then I've got my nice list component that I created. And then I've got each of the item components for each of the beers. And then you've got MD cards. So you've got this kind of elaboration of structure that you can actually inspect, which is very cool. And now we have cross-component communication, where the list is responsible for retrieving all of that from the network. But then it passes all of the items in to these more dumb components that are just given a beer, and they know how to render out that beer. That makes sense. Any questions on that before I move on? All right. The next thing I want to do is, I think I want to add routing to this application. So we've got this idea that you want to browse a list of beers, but maybe we want to add an about page to our application. So the first thing I'm going to do is I'm going to import the router. Your router. And then I'm going to add it as to my ng module. And I'm again going to use for root, and this time I'm going to pass in a route configuration. And so a route configuration is just an array of paths here. So maybe the default, click on home and then about before it loads. Oh, it actually did work. So we've actually canceled that request. So the web browser didn't still have to wait for that response from the server and then process it. Because we stopped listening to that observable, the HTTP library knew, hey, because there's no one listening to this, I'm going to cancel the request. And so it kind of cleans up after itself a lot more cleanly. Whereas with a promise or with the kind of traditional ways, there's no way to cancel that, where you'd have to do it yourself manually by building your own XHR.
Alright, good. Like, if you remove the async from the...
So if I remove async, this will not...
Yes. Then it will never fetch the data.
So what will happen is, I'm trying to iterate over an observable, which is not, an observable is not an iterable. It emits values over time. So if I wanted to do let beer beers, what I would have to do is I would have to subscribe to this. So I'd say this.beer. Actually, let's just get rid of this. And so I would have to manually subscribe. So I'd take this http.get, and I would say, I want to listen. So I want to subscribe, and then every time I get a value or a list of beers, I want to say this.beers equals list. But this would still, even if I did this, this would still update if somehow that HTTP observable emitted a new value. For example, in the case that I talked about before, where you're merging a local cache with an HTTP request. Another thing you could do, and I probably don't have the right operators here, is you could do something like .retry. And so what that would do is if that HTTP request fails, if that observable emits a failure state, it would automatically resubscribe to that observable. And so it would fail up to 3 times. And so it would try, which is a very kind of cool thing that is very hard to do manually. And the nice thing, if you think about this versus a promise, where a promise fails and I have to know how to go get that data, I have to know which service it was coming from so I can reinitiate that request. This retry just uses the observable stream and the chain there, and it asks the observable it came from to retry. And so HTTP knows how to retry because it's just resubscribing.
Shouldn't you now declare, if you do it like this way, it appears to be initially in an array, because when you render,
Yeah, it'll be null.
it will be null. Yeah.
Yeah, I think that should, let's give it a retry here for a second. Because I think if you try and iterate over a null, it's just nothing. That
It's about
worked.
the semicolon.
Yeah, okay. I think you haven't. Should have.
Should have worked.
Maybe put a semicolon back there?
No, because it's a chain here. It's actually,
Oh yeah, indeed.
maybe it's just
So in
slow.
the
It's on the console if you care about it. Yes, that's it.
Invalid argument. Oh, because I'm still async. We switched the type here, so
Yeah.
you need to save that file. All the code was right. Just need to save it. So what was the question? What were we investigating here?
I had the impression that BS should be declared initially as an array because it's null.
I think what will happen is we try and iterate over an empty thing and it has no items, so then no empty cards are being rendered.
Do components need to unsubscribe later to the observable, or
So if you use the async pipe, it will automatically subscribe and unsubscribe based on when the component is attached to your component tree. If I manually subscribe, then I would want to manually unsubscribe.
even when the component is not in view, it's not rendered?
Yes, because that subscription still exists in memory.
Okay.
Because that ES6 class isn't necessarily good. I think it, so we'd have to look into that. It may be automatically destroyed if there are no references to the component and the component is completely torn down. The garbage collector should grab it, but you should just, in terms of good practices, be explicit and unsubscribe from your observables. Yeah.
What if when you go to the about page and go back to the home page, I don't want the data to be fetch. I just want to use the data that we already know because, well, I don't know. So
say it again.
in this case, when you go to the about page and you go back to the home page, it will automatically fetch the data again from the server.
Oh,
so if you don't want
so there is an observable operator that used to be called cache and is now called share something. I see Robert Ratto. Basically, there's an operator that used to be called cache. What's the new cache called?
We haven't replaced it yet. It's going to be called cache left, I think.
No, it's share something.
There's share replay, share public, share...
Share something, and it will automatically do exactly what we want, where that observable will exist and be available. And then every time someone subscribes to that, it will get the previous existing copy of that.
So why isn't this cache?
Because there's 11 different ways you could use cache. So, like, you might want to just cache. You might want to cache until something else happens. You might want to cache while something else is happening. Right? So, cache, the simplest one, I think we thought was not what everybody expected it to be, given the name. So we pulled it out, and we're trying to decide, I think, what the new one's
There are months of history in GitHub, and you are welcome to join the conversation about why it's called cache and why it's not called cache. All right,
naming things is hard.
yes, that's true. So it's about 8:58. Do you guys want me to try doing lazy loading, or do we want to end? Yes. Okay. Lazy loading, resounding. So,
But whoever needs to leave before 9,
you've got 2 minutes.
you got 2 minutes. Otherwise, you leave with the whole group.
All right. So I need a new module. So let's create a. What do we call our new module? Lazy. Great. So once again, the Angular CLI, it's going to create a new module within my application called Lazy here. Within there, I'm going to want to create some routes. This is not a component. This is not a module. What am I doing here? All right. So in here, we're going to add our router. We're going to import router module.forChild. And here we're going to pass in a path, so we'll just call it open here, and we'll say component, lazy component. All right, so now we have a module that's separate, and so it has its own context, it has its own dependencies, etc. And now let's actually refer to that from our main router and our main module here. So I'm going to get the syntax wrong here, but I've got a handy-dandy reference. So we're going to call this /lazy. And then instead of component, I'm going to call it load children. And then I'm going to pass a big fancy string that System.js uses to find the child module here. Just copy that. App lazy.module. Lazy module. Could have just called it admin. Might have been easier. All right, and that should be it. Let's give this a try and see what I've messed up. Oh, we need a way to navigate to our lazy path. So let's our app component here. All right, so we now have a link here. So when we click on /lazy, it should load that separate chunk that the Angular CLI has built for us. And I'm not seeing a chunk here, so I've done something wrong at least. Rob, do you see what I made? Where I made a mistake here?
Should that not be relative?
No, I don't think so. I can try. Here, let's just see what the error is. Cannot find module app lazy. Let's try making it relative. Did I miss a dot or something when I copied?
No.
Did you include it? What did you do?
That should work.
Actually, I shouldn't have late app here, should I?
Yeah, you can just be fully relative or fully absolute.
Let's try that. So I'm watching the Angular CLI to see what it's outputting. So it's still not finding that. I did this twice today. It should work. Let's take a quick look at my reference. And is it called lazy module? It is called lazy module. Why don't we kill the CLI? Restart, see if that helps. Shouldn't matter. Oh, it did matter. I must be running an earlier version. So we did everything right again, we just didn't save. Isn't that fun? All right, so as you saw, or I probably went too fast, we've now emitted a code split chunk. So that child module, that lazy module, is only 3.8 KB. And this is all unminified, unproduction code. This has all the comments in the entire Angular framework, not true shaken out. And then what's going to happen is when I click on lazy, we should see that chunk load and render.